I'm looking at my writing here. It's a little small. Sorry about that. But here's an example where we want to build a rational function that has certain characteristics. In this case, we want it to have a vertical asymptote at x equals 5, a horizontal asymptote at y equals -3, x-intercept at 2/3, 2/3 0, I should say, and y-intercept at 0, -2/5. Okay, so the goal is to build the rational function that will have all these traits. I've already decided to reposition this thing. Okay, so we want to build f of x equals some polynomial over some polynomial, rational function. So to build this thing, you have to think about where each of these traits comes from in terms of the equation. So vertical asymptotes come from setting the denominator equal to 0. They're the zeros of the denominator corresponding to the factors that don't cancel. So if we get x equals 5 by setting the denominator equal to 0, then that means we would have x minus 5 in the denominator. That's what we get from the vertical asymptote at x equals 5. If that's a 0 of the denominator, then we must have x minus 5 in the denominator. Okay. Horizontal asymptote, if you remember, so there were these rules about horizontal asymptotes. When you're looking at an equation, if there's a higher degree in the denominator on the bottom, then the horizontal asymptote is y equals 0. So that's not what we're talking about here. If there's a higher power on top, then you don't have a horizontal asymptote. You have a slant and oblique asymptote, and that's not what we're talking about here. When you have the same power on the top and bottom, that's when you get y equals some non-zero number. And the non-zero number comes from the ratio of the leading coefficients. So the ratio of the leading coefficients must be -3. So we could think of that as -3 over 1 for our leading coefficients. Now, the other thing I said, though, is you get a horizontal asymptote like this, y equals -3, just y equals any non-zero number. That happens when you have same degree top and bottom. So I already have x to the first on the bottom. I must have an x to the first on the top. This thing needs to stay balanced in terms of highest power of x if we're going to get a horizontal asymptote at y equals -3. X-intercepts come from the zeros of the numerator. So the fact that there's an x-intercept at 2/3 tells us that 2/3 is a 0 of the numerator. So that means we have a factor like x minus 2/3 in the numerator. That would give us that x-intercept at 2/3. Because remember, the x-intercept comes from setting the numerator equal to 0. Okay. Y-intercept at 0, -2/5. So the y-intercept comes from plugging in 0. The fact that there's a y-intercept at 0, -2/5 tells me that when we plug 0 into this function, the output is -2/5. So we could just test out the function the way we have it here. Now notice one other thing. If I distribute the -3, that would actually make this numerator look nicer. So I'm going to go ahead and do that. In your homework, I've set it up so it's okay if you write your answer in a different form. So an answer like this should be accepted by MyMathLab. But it does, notice it does make it look nicer if we distribute that -3 because of the denominator that's 3 here. So -3x, and then when I distribute this, that'll be plus, because it's a negative times a negative. The 3's cancel, so just +2 over 1 times x minus 5. Okay, so this is the function that we've built so far. Right now, I just want to verify that we've satisfied this condition here. So if I plug in 0, that'll be -3 times 0 plus 2. Over 0 minus 5 will give me -2/5. So I'm just kind of verifying that, yeah, the y-intercept for the function that we've built here would be -2/5. So this is the function that we're looking for.